problem's asking for us to write the equation of the function shown. So first thing I'm going to do is I'm actually going to zoom in really far on this graph because I'm old and blind, y'all. I don't know what that says. So here's a nice big version of that graph. Now if you notice, this graph has two colors, yes, but it could be an absolute value graph. So what we need to do is actually first check to see if it's absolute value. And so what I'm doing is I'm checking the slope of the right-hand line and the left-hand line. And you can see when I put in my anchor points that they are not, they're not symmetric. So this is not an absolute value graph. So we can get rid of those two absolute value expressions. However, this bad boy is a piecewise graph. So what we're going to do is we are going to set up a piecewise function, which means that you put f of x equals and then that little like swirly swoop that I don't know the name of. And now we need to actually go through and define the expressions. Now recall the slope-intercept of a line is y equals mx plus b. So for both the red and the blue line, I need to identify my slope and my y-intercept in order to write my equation. So this red line is going down by 2 and to the right by 1. So it's a slope of negative 2 over 1, or just negative 2. Now the y-intercept is a little bit harder to tell, but what I'm going to do is I'm going to continue that slope downwards, so falling by 2 and running by 1, and that'll get me where this red line would cross the y-axis, which is here at 4. So if I'm plugging in the mx plus b here, my m of negative 2 goes times x, and then plus 4. And we'll talk about the domain here in just a moment. So just leave a comma and we'll get there. So now for our blue line, I'm going to do the same thing. So on the blue line, it's a positive slope because it's rising. And I could see that it's rising by 3 and running by 1. So it's a slope of 3 over 1, or just 3. And that y-intercept is right there on the graph for us. That's super nice at 9. So the equation here, the mx plus b, would be 3x plus 9. And then we put a little comma because now we have to describe our domains. So what I do to help me to see my domain is I actually tend to color the graph anywhere where that part of the line is. So my blue line is taking up this part of the graph, which I'm going to get a little wild with my coloring. Y'all imagine that it's a good coloring job, alright? That's what I need from you right now. And then the red line takes up this part of the graph, so I'm going to shade, got a little too excited with the red, so we're going to try that again. Stay within the lines, y'all. Stay within the lines. I apparently need to work on that process. There we go. So here is the red place, there's the blue place, and what we need to do is we need to define which values of x are red and which values of x are blue. So if I look, these guys are cutting off at negative 1. So the inequalities that I deal with are dealing with negative 1 for x, either less than or greater than. And so the red is shaded to the left of that, so x is less than the negative 1 for red. And the blue is shaded to the right, so x is greater than for the negative 1. Now it doesn't matter which one of these I choose, but I need to pick which function I would apply the vertex at. Alright, because they're meeting at this vertex here, it could be either one. These ones both have this top line having the little tick mark. So now we just need to identify which of our solutions works here. And so if you notice, the negative 2x plus 4 and the 3x plus 9 lines up right here. And they actually had the tick mark on this one because I was out of order. Oopsies. There we go. So now we match a little bit better.